So welcome to this F5 NGINX Google Cloud webinar entitled Essential Tactics to Protect Your Apps in Google Kubernetes Engine. My name is Robert Haynes. I am technical marketing across at NGINX. I'm joined today by my colleague Mark from Google. Mark, do you want to introduce yourself?
I'm Mark Dam. I'm the F5 ISV specialist in supporting our security partnerships at Google.
Excellent. Okay, so Mark knows all the answers to how we work with Google together, and how you can get some of this F5 technology. Okay, so what are we going to talk about? Well, the first thing we're going to talk about briefly is the Google and F5 partnership. Then I'm going to talk a little bit about the Google Kubernetes Engine, otherwise known as GKE, and then how we protect apps in GKE from layer 7 attacks, some architectural and some design considerations. Then Mark's going to take over and take you through some information about acquiring this technology through the Google Cloud Marketplace, and then we might talk about what the next steps are.
So Google and F5 have been delivering security partnerships and security solutions since 2016. So we've been at this a while in the realm of bot protection, application security, and online fraud defense. And fundamentally, with our partners, we want to be able to deliver apps faster, reduce the cost of those delivery, make them secure in the development and runtime environment, and also reduce the friction in the procurement cycle by making it a one-stop shopping experience through the Google Marketplace. And we'll talk more about Marketplace later. But the point is, with our joint solutions, we have lots of resources dedicated to working at the product level in the partnership, the go-to-market, and the procurement side of things. So we have a very solid solution together, and we regard F5 as one of our top ISV security partners. Thank you. Back to you, Robert.
Excellent. Okay, so let's talk briefly about GKE, the Google Kubernetes Engine. Presumably you're at this Google Kubernetes Engine webinar to find out a little bit about how you do Kubernetes and securing it. So if anyone has played with Kubernetes or uses Kubernetes, we all know that it's a great platform. It's fantastically powerful. It's a great place to run your container-based workloads. But we also know that there's lots of things about running it that are kind of a bit of a headache, which is why you really should be adopting some kind of managed service. And obviously, if you're going to do this on Google, the Google Kubernetes Engine is the place to do it, because it gives you so much of the things that make running Kubernetes sort of more possible and easier. Things like automatic scaling, scaling your nodes up and down to meet demand. Node repair, when something breaks, when a node needs to be repaired or replaced, this is all happens automatically. Upgrading, I mean, no one likes upgrading anything most of the time, but automatic upgrades to your GKE environment. Better security than you might get if you took it straight out of the box. Great external load balancing and logging and monitoring. These are all the things that make like running Kubernetes in production. They're all mandatory. You need to have them. If you do them by yourself, they're hard work. A managed service just makes a ton more sense. So great. Hopefully we've established that running applications in GKE is a good thing. Obviously, you need to secure them. Nearly every cloud vendor, Google included, runs a shared responsibility model. This means that they take responsibility for some things and you take some responsibility for others. Now with Google, they take responsibility for securing the Kubernetes distribution. This is really powerful. They will look after the security of the underlying Kubernetes infrastructure, the distro that's running. The control plane modules, the control plane nodes are run entirely separately. You don't have access to them. Hopefully nobody else does, except for Google has access to the control plane components of Kubernetes. The actual operating system that's running on the compute nodes is a secured, container optimized operating system, again, to give you the best possible baseline security. And obviously they integrate with the rest of Google Cloud for things like authorization, authentication, and logging. So they give you a really solid, really good security foundation. But there's quite a lot of it that's down to you. And that's basically the application and the node. So if you think about what's running inside there, the nodes that make up your pods in your cluster, the operating system that's running inside of those nodes, inside of GKE, and of course the application that runs on top of it, those are the things that are down to you to secure. Now, I get in trouble when I say that, that gives you the hard job and Google the easy job. It's kind of not true, because, running a secure Kubernetes environment is a lot of work, but they've got a considerable advantage of the scale, because they do this for everyone all around the world. Your application is often unique to you, and so you've got to look after the security of that. So you kind of do have the harder job, really. But on the bright side, the GKE gives you really good, powerful tools like really strong authentication, authorization, and audit. So this ties into the Kubernetes RBACs integrated with the Google Cloud IAM services. So all the way you control access to the rest of your Google environment, you do the same into Kubernetes. Control planes security, as I said before, are isolated instances run by Google, hardened operating system. You can restrict the capabilities of pods and containers with container security context. You can control traffic to and between pods with network policies. Those are all really powerful tools you should completely take advantage of. But you then still are left with this big kind of like thing to worry about, because application layer attacks are still a very prevalent risk. Now, if you have experience in the security world, you'll look at these attacks that I've got up on the screen and go, okay, injection attacks, path reversal, cross-site scripting, cross-site request forgery, CSRF. These are old attacks. These are nothing. This is not some sort of cutting edge zero-day stuff. These are, I think injection attacks are probably old enough to drink by now. But what I will say is, when I was putting these slides together maybe a month ago, I did a quick Google search, funnily enough, and these are all things that have caused actual real-world production-level compromises in the last few months. So although they've been around a long time, they haven't gone away. We're still dealing with these things on a day-to-day basis, and you should still absolutely be concerned about preventing these kind of attacks against your application. Because if you do get attacked, the kind of results are obviously data access or deletion. So someone's going to steal your data, someone's going to delete your data or encrypt it. Credential theft, stealing credentials through things like form jacking or other methods of hijacking sessions. So if someone's stolen my credentials, okay, if it's my Animal Farm login, that's a pain. But if it's my banking details or my eBay account or whatever, that's considerably worse. The same for session hijacking. Once you've hijacked my authenticated session, you can do what you like with that, and the damage that can do can be considerable. But you might not even know that someone's compromised you, because it might be part of a wider reconnaissance activity. So as part of sophisticated hacks, where maybe professionals are involved, one of the things they are going to do is use maybe relatively simple hacks for reconnaissance purposes. They may not make any obvious sort of spottable, detectable changes, but by just knowing what's running on your systems, by having access to them, can give them an important leg up the ladder to a more serious compromise. Okay, so how and where do you prevent application layer attacks? Well, the best place to start is right at the beginning. So software supply chain attacks. Everyone's heard of software supply chain attacks. The definition is maybe slightly vague, but we do know that people are using software libraries. Today we build applications from components. There's probably almost no modern application out there where every line of source code was written by the people using it or the people writing it. We're always pulling in libraries from places, whether those are kind of like Node packages or Python modules or whatever. We're always using modules to do stuff, because who wants to, I don't know, write the code from scratch to deal with dates or padding spaces or any other kind of really common operations? We use modules for it all the time. And people are attempting to compromise those modules. They're doing things like, typo squatting. I'm a terrible typist. In fact, we'll be lucky if we get through this presentation without us spotting a typo in the slides. But that means if I when I do my package import, if I mistype, there may be a package that actually works. It does exactly what the package I meant to use does, but it's going to cause me problems as well, because it brings with it some added poison. Okay, so software supply chains are really important. Google have actually offered a secured software library, so you can subscribe to use, instead of the general purpose repos of the languages they support, you can use the Google supported repository of all those modules, and they are the same modules that Google are using building their software, and they've obviously very carefully looked over that and examined those modules, so they're safe. And you should absolutely be using things like software composition analysis and secure supply chain in building your applications. The other thing you need to do is obviously test your code and build it securely. So, you know, if you're using any of the build pipelines or the build technologies that Google offer, you should absolutely integrate secure coding testing and testing your infrastructure deployments as part of that. So should completely be building a secure software pipeline where your code is tested, your developers are working in a secure coding environment with training and all those good things. So, you know, by the end of the time that you get through, you're using secure components, you are building and testing them carefully. So at the end of the day, they pop out into production, and when they're exposed to the big bad world and people are trying to attack them, in the best possible shape they can be. But you still have to have runtime protection, and this is where we're going to spend most of the rest of this webinar talking about, because this is the technology that F5 NGINX have, is you need to protect your running applications from attack in production. So if you could guarantee that the first two steps that we've just seen are perfect, you're using absolutely invulnerable components, you've built your software to perfection, completely invulnerable, and there are going to be no discovered zero-day attacks in any of the components, then yeah, you don't need runtime protection. But that's not the real world. That's not the world we live in. So you absolutely have to have this kind of final runtime protection layer, so that when your applications are running, that they're protected against attack. So how do you do that? What do you need? I think there are three essential things that any kind of runtime protection has to have. First of all, it has to understand, okay? So you need to look at an application request or a response or any kind of connection via API as it comes in and understand it in the context of that application. You can't just look at the ones and zeros in the packets and stuff like that. You have to be able to understand that application, the traffic coming in from the outside in the context of the application. You then got to be able to evaluate it. Obviously, first thing, you've got to understand it. Then you need to evaluate it. Is this a valid request? You know, does it conform to the API spec or the protocol spec if it's HTTP? You know, is it malicious? Does it contain clearly malicious attacks? You know, like, you know, patterns that we know are liable to be trying to cause compromise. Is it malformed? You know, things like too long fields, buffer overflow attacks, all those things where we don't validate user input correctly in our applications that can lead to overwriting memory in other places. So you have to understand it, you have to evaluate whether it presents a risk, and then you have to act. So do you block the request? Do you stop the request ever getting into the application? Actually, you also need to evaluate your responses as well. So do you block the response? Does the response contain something it shouldn't do? You know, I'd suggest that if the response coming back from a server contains a huge long list of credit card numbers in plain text, that's probably a bad sign. The same for social security numbers or any kind of the national ID of whatever country you're living in. So, you know, do you want to block the request from ever getting there? Do you want to block the response? Or do you just want to raise an alert? Do you just want to raise a suspicious situation so that maybe we'll allow the request through, but it requires further investigation? Maybe it's fine, but maybe it's not. Okay, so the kind of industry solution to this is some kind of web application and API firewall. They're a layer 7 security solution, usually combined with other layer 7 services like load balancing. You absolutely, and we'll talk about the architectural positioning about this in a minute, but you know, you can have standalone services in the old school world of, you know, data centers with things in racks. You know, fewer things in racks is generally better. And obviously the fewer number of network hops that something's passing through a physical device is better too. But in the virtual world, that's maybe slightly less of an issue, but you still want to combine as many functions as you can into one layer, just for the purposes of management. You know, and a WAF evaluates application traffic, detects threats and compromises, and blocks and alerts, or just alerts, depending on how you have this configured. So to be a good WAF, so that's what a WAF is, but to be a good WAF, it has to have, again, three things. I think my brain thinks in threes, but you need to be comprehensive. So you need to block things like common attack types, you know, all those SQL injection stuff. You need to have some API security, some bot detection, some data leakage protection, that ability to evaluate responses as they come back. You know, again, you need to be able to look at the protocol compliance. You know, we know that the headers should be a certain length. We know that HTTP 2 looks different to HTTP 1.1. You know, we know that a gRPC call looks different to a REST API call. And there are specifications and protocols that that are designed to kind of protect stuff. So we know how long fields should be and all sorts of stuff like that. So we have to have compliance to protocols. We need to be able to spot if someone is trying to evade things. There are loads of evasion techniques. If you go and Google like WAF evasion techniques out there, you'll find tons and tons of stuff. You use loads of escape characters, you encode stuff. Your application firewall needs to be aware of all this stuff. It needs to be wise to those kind of tricks. You need to be able to turn things into blocking and transparency mode. There's a sad tale of people that have too many alerts coming from their WAFs and too many false positives and put them into transparent mode. Transparent mode is not my favorite thing, because all it does is produce logs and noise and alerts, but doesn't actually protect you. But there are certainly cases where you should have it, and you should be able to differentiate when and where you do that. And obviously, you need to be able to provide great logging and metrics. Threat feeds into your security infrastructure, metrics about performance and whether you need to scale, all that sort of stuff. The second thing is that that rule, like, be accurate, don't be inaccurate. The biggest problems we see with WAFs in general across the whole industry, this is not picking on any F5 NGINX competitors, I'm not picking on NGINX, but the two biggest problems we have with WAFs in general are inaccuracy, leading to false positives more than false negatives, and the operational overhead of running a WAF. And I'll talk about that in the next section. But you've really got to make sure that your WAF is A, sensible in terms of what policies it has turns on and what policies you've configured, B, accurate, so that you don't get a ton of false positives. Because if all you get is false positives and false alerts, A, you're probably going to put the thing into transparent mode, or you're going to start ignoring the alerts, and then your WAF is essentially useless. It's just an operational overhead that's providing you no value. But that's down to having good, accurate policy sets that don't produce too many false positives. This brings us on to aligned. You've got to keep the overhead low. Security policies and security solutions that break the operational flow of an organization who's trying to deliver applications are another huge cause of WAF failure in terms of the projects. So whatever WAF you choose, and obviously I'd love you to choose F5 NGINX and our App Protect WAF, which I will talk a little bit about, but whatever WAF you decide to choose, and however you run it, it shouldn't necessarily be like a speed bump on the way from getting your app out there. It should be a way to accelerate that, because you can align the testing, you can put it out with better protection. But so that means that how you operate the WAF is as important, and how the WAF can be operated is as important as these comprehensive and accuracy things. This is just a simple example for people who are more visual, and myself included. I think I started with this diagram and then decided that I needed some words, but your WAF has to be able to evaluate everything and block all the things: malicious requests, bot requests, unsafe responses. You have to be able to block all of those things from your WAF before it gets and starts causing too much damage. Now, you can argue that if you're getting an unsafe response back from your application, then some damage has already been done. If somebody's been able to craft a request that's produced a response that has all my details in it when I didn't want you handing out all my details, that's a bad thing. But at least at this point, we've mitigated the damage. Okay, so let's talk about architectural considerations. There are, I think, amazingly, everyone's going to be shocked by now, 3 places that you can put a WAF to protect your application running in GKE. The first place is somewhere in the cloud. Now, this is not a bad place to put things. There are cloud WAF solutions out there that you can take, including ones from F5. And these are actually an incredibly good place to put any kind of denial of service or bot mitigation solution. Anything that's potentially like large volumes, any volumetric attack protection. I always think like a volumetric attack protection, I want as far away from my application as possible. Where do I want the kind of like that the big dam against the influx of stuff? Well, I want that as far away from me as possible, because I don't want to affect any of the infrastructure I have to worry about. So you can definitely put a WAF in the cloud. That's fine. It sometimes leads to operational issues about how you're running things, because often we want the WAF to be very tightly tied to the application. There can be not an air gap, but like a cultural and a team gap between those two teams sometimes. So maybe a WAF in the cloud is a great place to put some sort of brute force, sort of blunt instrument policies, but it's not always the right place to put sort of a finely controlled, finely grained WAF policy to protect your applications. And also sometimes that allows some sort of go-arounds and some evasion to happen. The next place is external. So external, but local to the cluster. So I have a GKE cluster. I can put a WAF outside of that infrastructure. In infrastructure inside of GKE, I can run a WAF as a standalone on a machine instance in GKE. You can absolutely do that with NGINX and our AppProtect WAF. Again, it's a perfectly fine place to put things. You can then protect traffic to multiple clusters. So that's perhaps a good thing. Again, a lot of that choosing of these positions boils down to operational rather than technical issues. So if you really want the team that run maybe the Kubernetes environment to be running the WAF, because they'll know what applications are going on, they'll know what ingress to configure. Maybe an external solution doing WAF technology or WAF protection is going to produce some operational friction about how, I've set this up inside of Kubernetes. Now I need to go and talk to somebody about getting a WAF policy and a configuration on an external box that's not inside my cluster, not inside my control. That might be fine. Kind of depends how you set up and how you're running. But again, it's there's a chance for operational overhead. I think my personal favorite is at the Kubernetes ingress controller. So, in Kubernetes clusters, we use an ingress controller. An ingress controller, amazingly, controls ingress to my cluster. So it receives incoming requests from outside of the cluster. It makes essentially routing decisions based on which application that traffic should go to, and it routes to a service inside of the cluster, and then eventually to a pod. So maybe some calls coming in go to the yellow boxes, some calls coming in go to the red boxes based on the host name or the URL or other factors like that. And so an ingress controller is really a pivotal part of your Kubernetes ingress and your Kubernetes traffic management. So a WAF is a really smart thing to put there because it could be controlled by the same people that are configuring everything else. So if you're responsible for configuring ingress for a new service running in your Kubernetes environment, being able to enable a WAF for that at the same time and the same policy is super easy. And therefore, I think it's the most likely sort of configuration that's going to end up with everything protected. Okay, so NGINX makes a Kubernetes ingress controller. There is in the world of Kubernetes, the NGINX community version is kind of the default reference implementation. NGINX ourselves also make a Kubernetes ingress controller, and I would argue that it's slightly more enhanced over the community version. There's nothing to say there's anything wrong with the community version. We certainly make a slightly more enterprise-ready version because we have things like rate limiting, split routing, authentication, conditional routing. The way that the ingress controller behaves during updates is better. It produces less latency during configuration changes than the community-supported version. So in general, it's a better version of an ingress controller. The other really good thing about it is that you can add the NGINX AppProtect WAF to it. So that's maybe take a brief pause. I don't want to turn this into a massive infomercial about NGINX technology. I really want to, get value to people. But the NGINX F5 NGINX AppProtect WAF is built on F5's leading WAF. So if you go and look at the WAF evaluations out there, you'll find that the F5 Big IP Advanced WAF, we love naming things long at our company, is a really powerful industry-leading WAF. We took the core of that code and we loaded it into a lighter weight, lower latency component that you can run alongside inside of your ingress controller as part of your Kubernetes traffic management solution. So it's built on exactly the same technology. It does not have every single bell and whistle because you don't want that at this point. You want a really powerful, really lightweight WAF that's operationally aligned with how you're doing things. And it's low latency, powerful, still very configurable, and integrated with ingress. So it's a great place. My favorite place to put WAF technology is close to applications. In Kubernetes, I really want that part of my ingress controller, and I want to be able to enable that as part of my ingress control. So this is how we configure the WAF inside of ingress control. So anyone that's familiar with Kubernetes, you'll recognize this manifest file I have up here. And really, to turn this on for my ingress policy, all I need is this one highlighted line. And so that makes adding this WAF functionality to an ingress configuration really, really super simple. Now, there are some other things I can turn on too. I can turn on a policy. If I don't specify a policy, it uses a default one. I can specify policies. I can also configure security logging separately to other logs. That's really useful because often the team that's looking after the general platform operations or the application operations that's maybe getting logs from Kubernetes is not the same people that you want to respond to a security incident. Now, you may want it to go to both places, but it's probably often quite important to send security related logs to the right system and the right team. So being able to send the security logs somewhere else away from the application and general Kubernetes logs is a really powerful tool. Finally, I've been talking about operational alignment a lot during this webinar, and because it's really important. The way that we see this working is, we have a deployment pipeline, we have a CI/CD pipeline, call it what you like, and we keep in that pipeline in source control, we will keep our application code, our container build scripts, our application code, so that we can push an application out the other end fully built and tested. We're also probably going to keep some of our infrastructure code in there. So, the Google deployment manifests, any kind of automation tools we're using to build the infrastructure to deploy the application. That could be Kubernetes manifest files. It could be anything. So I keep in source control my application code and my infrastructure code. And with F5 NGINX App Protect WAF, I can also keep my security code because the security policy is just a JSON file. It's exactly the same kind of file format you'd see for other kind of configuration files, and it is editable if you so desire. And so I can keep my security policy alongside my application code, alongside my infrastructure code, and I can manage all of those so that if I make a commit or a change or a merge request to any of these things, that can configure a build and a test and maybe a deploy, depending on how I'm set up. So that way of building this operational alignment where I can have potentially still the security policy owned by the security team, but kept in lockstep with the application and the infrastructure code and deployed in exactly the same way is a really powerful implementation. So that, as the build of everything else happens, and that's managed by a platform ops team or a DevOps team, and that all gets pushed out, the security policy is managed in exactly the same way. So, just to reiterate what I've said, WAF's important. It's the kind of like the thing that protects your application in live. That doesn't mean you shouldn't have all the tools along the way so that you end up with the healthiest application pushed out into production. It's important that your layer 7 protection technology can understand traffic, can evaluate it, and can protect against it. I think a really good place to run that is at Kubernetes Ingress, because it's aligned with how you set the rest of your ingress up. I think the most important factors are accuracy and operational overhead. So being able to run your WAF that's accurate in the way that you run the rest of your environment is the most important thing. With that, hopefully everyone's now thinking, this is great, how do I get this? And I can hand over to Mark, who can take you through the Google Cloud Marketplace.
Many of you may be aware of the purchasing co-sell motion that Google and F5 have together. There's such a path called ISV Solution Connect, where a purchase would take place on F5 paper. But what we're promoting is the Google Cloud Marketplace, which, as you can see, has a variety of solutions, our ISV, independent software vendor partners, available. It's a procurement platform. It's a centralized billing, a diverse selection of payment methods, and ultimately one bill from Google of tested, integrated, and supported applications. I don't need to elaborate too much on the benefits. Certainly, there are certain financial incentives and discounts that are available through the marketplace. The procurement and fulfillment is fast, and this is a really important utilization of your OpEx or CapEx dollars to get these solutions to market quickly and clearly This is the case for in the sense of urgency around application security, and runtime application security is very paramount these days. And it allows you to have a centralized billing capability and consolidate your vendor relationships. We have a handful of the NGINX solutions available on the marketplace, and keenly available on all major operating systems, including Windows servers. So, as you may be aware, the Google Marketplace has been doing a lot of catch up lately with its capabilities. There's some new features with a variety of subscription models, payment and installment plans that have a greater variation than we've had in the past. The ability to implement some custom EULA or end user license agreement terms, and the ability to augment or modify purchases. In the early revs of Marketplace, a lot of these features were not available, but we're proud to bring them to market now. We're building for the future. This is a really powerful partnership, and obviously in these challenged economic times, this is often the engine for change, and a lot of our customers have to look at better, faster ways to do things to offset some of the challenges with headcount, and deploying these solutions in the cloud is paramount at this time. So, thanks for this opportunity.
I think it's probably fair to say that if you have questions about the NGINX App Protect for App or other NGINX solutions, then you should talk to us. You'll get an invitation to a trial. For information about the Google Marketplace and how you can procure this in a kind of as part of your IT spend, then Google will be in contact with you as well. They're great joint solutions. We love working with Google. They're one of our strongest cloud partners. You'll get some follow-up information from us. And with that, I think all there is to say is thanks for watching.